Hello everybody and welcome to this loans video. I'm suffering from a bit of a cold, so I'm sorry if this thing is not the best. Before we get into the examples, I think we should cover some terms. One is actually just let's talk about a loan. A loan is an agreement to borrow and repay money. Interest is charged as a fee for the privilege of borrowing the money, which means if you borrow $100, you're going to be paying back more than $100. The majority of loans use compound interest, but simple interest is available, not likely through a bank, but maybe through a family member or something. A loan can involve regular payments or a single repayment at the end of the term. Also, I want to talk about a mortgage. We're going to leave a mortgage as simply a loan designed for the purchase of real estate. So mortgages are going to be a lot more, going to be a higher value. So how do we solve or how do we calculate values with loans? Well, there's some formulas. First of all, if it's a simple interest loan, we're going to use our basic simple interest formula, so nothing new there. If it's a compound interest loan, then with a single repayment, then we have our basic compound interest. If it's a compound interest loan and we have regular payments, so maybe it's monthly payments or biweekly, we could use this formula here. Or we could also use our time value money application in our calculators. So we're going to use the calculator, so we're going to speed ourselves up when we're working with those ones. Example 1. Lars borrowed $12,000 at 5% compounded monthly to buy a new personal watercraft. The bank will use the watercraft as collateral for the loan. Lars negotiated regular loan payments of $350 at the end of the month, or at the end of each month until the loan is paid off. Part A. How much money does a watercraft cost Lars once the loan is paid off? Okay, the first thing I want to remind you guys of is just how we actually get through one of these questions, or how we decide what we're going to use. So here's our question. First thing we have to decide, is it going to be a simple interest question or a compound interest question? If it's simple interest, we use that formula. If it's compound, though, we have two more questions. Is it going to be a single repayment, or is it going to be regular payments? Remember, single repayments will use a formula as well. So this will be formula. This would be formula that we've talked about in the other page. And then this would be our calculator, TVM. All right, now that we got that out of the way, let's start looking. Okay, so first of all, I see compound, so I know it's compound interest. So now is it a single repayment or regular payments? And right here it says regular loan payments. So I know I'm using my calculator. Now that I know I'm using my calculator, I'm just going to go ahead and write down our little variables here, or our settings. All right, I'm going to fill things in. So interest is 5%. Present value. So the present value is going to be the principal for your loan, like what amount of money you actually borrowed. We're going to make that negative. So negative $12,000. The payment, it says $350. The future value. So it's always going to be zero, everybody. Now that is a change from the previous unit, investing. In investing, our principal was zero. Our future value would solve for it. With loans, our principal we're going to always know, and our future value will always be zero. Payments per year, 12, because it says at the end of each month. And then compounds per year. Back up here, it said compounding monthly. Man, that's getting messy up there. Sorry about that. So once I have all that, I plug that into my calculator, and I would get 37.07 for my end value. Now, what does that mean? Well, that means we're making 37 full payments and then 0.07 of one more payment. So depending on how things work, maybe you even bump that into your 37th payment, but we're going to say that's really 38 payments, 37 full, and one more very small payment. Now it says, how much does the watercraft cost Lars once it's paid off? So what we want to do here is to figure out the cost. We have to figure out, okay, well, what was his payment value, and then how many payments did he actually make? Remember, N is the total amount of payments that you're going to be making. So 350 times 37.07. So that is going to equal $12,974.50. So this is how much in the end that watercraft actually cost Lars. Part B, and just in case you're wondering, I just have the same little write-up. I'm keeping that on the page in case we have to refer back to it. But Part B says, how much interest will Lars have paid by the time he's paid off the loan? Okay, so previous unit, our interest was A minus P, future value minus present value. So that kind of makes sense, or it still does make sense, but it might make more sense to go something like how much you paid in the end minus how much you borrowed. So I'm wondering if that language might be a little bit easier, but truly it's the same idea. So in the end, he paid $12,974.50, and he borrowed only $12,000. So the difference between that will be his interest, which would mean $974.50 worth of interest. So to find that interest, we simply use that subtraction, same as in the previous unit. Part C. Suppose Lars had decided to make $400 monthly payments under the same loan conditions. So everything's the same as previously, just a higher payment. What effect would the greater payments have had on the time to repay the loan and the amount of interest charged? Well, off the top of my head, I don't know what kind of effect it has. So I guess let's actually solve the situation and then compare it to the first one. So that means we get to use a calculator again. Some dead air here as I write this stuff down. So interest is still 5%. He's still taking a loan out for $12,000. Remember, notice that I am making that negative, make that stand out a bit. The payment is now $400. Future value will be 0 because we're paying this thing off, so that's why that's 0. It's still monthly payments, and it's still compounding 12 times a year. All right, so plug that into my calculator, and I get 32.11. So we can see that we have less total payments. So less total payments means it's going to be, it's going to cost us less. There'll be less interest calculated or accrued over this time. But we can confirm that and see the cost. Again, the cost is going to be the payment value times however many payments this person makes. So $400 times 32.11. So 32 full payments and then 0.11 of one final payment. And that equals $12,844. So what effect would it have? Well, the larger payment means we're going to pay it off quicker. And if we pay it off quicker, there's going to be less interest. So it's going to be cheaper for us to take that route. Example 2. Trina's employer loaned her $10,000 at a fixed rate of 6% compounded annually. The loan is to be repaid in a single payment on the maturity date, which is at the end of 5 years. Maturity date means just the date that your payback payment is due. Anyway, how much will Trina need to pay her employer on the maturity date? So when this money is due, how much is she going to have to pay back? Well, before we get into that, we have to think, okay, is this a simple interest or compound interest? Okay, compound interest. So is it a single repayment or multiple payments? By default, I want you guys to always think everything as a single payment. And if you see language like monthly payments or bi-weekly, every 6 months, something like that, then we'll make the adjustment to regular. But I want you to assume single payments all the time. And in this one, it actually even says single payment. That's kind of rare. So I know that this is going to be a formula question. So formula for compound interest, sorry. I'm losing my voice a little bit. All right, so she's going to loan her $10,000. So the principal for the loan is still $10,000. The A is going to be the future value that she has to pay back now. The interest was 6%, which is, we have to remember, we have to put that as decimal form when we're going back to the formula. A lot of students make that mistake. So make sure you put it in as a decimal. N is the compounding frequency per year. It says compounded once a year. And the time, it said 5 years. So I've got everything here. Now I just have to plug it in and solve. So I'm writing my formula out. Place my values in. N value is 1, so it's kind of feels weird just to put it over 1, doesn't it? Anyway, there's all my values plugged in. If you want to show some progression, like kind of show some more steps now, you can go for it. Otherwise, you can go straight to your answer. So $13,382.26. Now, if you find that you're a few cents off or a few dollars off, that will always be because of rounding, you guys, okay? So we're not going to worry too much in this video about the rounding, but in class we can talk a little bit more about that. But that is how much she'll need to repay her employer. B says, what is the accumulated interest on the loan? So again, just how much interest was charged. Same idea. We're going to go what she paid minus what she borrowed. And that'll tell us how much interest she had to pay. So she had to pay back $13,382.26. She only wanted to borrow $10,000. Only. That's a lot of money still. That is some easy math now for us. We get $3,382.26. So that would be the interest that she was charged on that loan. Okay, so I'm going to stop here for today. I'm going to make a second video because this can get kind of long, but hopefully this can get you started at the first part of your assignment. And again, look for the second video. All right, everybody, have a great night.